All right, so you made it through section 2.1. We'll just jump right into section 2.2. It's going to feel a lot the same as 2.1. The concepts are a little bit different, but the idea is going to be the same, that I will lecture on any theory that I need to lecture on. As I'm doing the lecture, I will do even problems. You'll have an odd problem that's posted on the screen as I do my even problem, and you can do the homework just as we're going through the videos. That's kind of my hope. So problems 1 through 6, again, if I just looked at the problem without an instruction, it doesn't tell me what to do. So I need to look at the instructions and know what the instructions mean for me. It says, the instructions say, plot the points on the graph, then find the distance between the points. So when I wrote these problems, here's what I had in mind, and then I will show you an alternate way to get the distance between 2 points. So ultimately, my answer is going to have 2 points plotted, and I'm going to say the distance between the 2 points is, I know what the answer is, but I won't write it down. I'll show you how to, 2 ways to get it. So the way that I envision students getting the answers to this question is to take each point that's given and plot them. So the first point's the point 1, 2. I'm going to plot it. The second point's the point 4, 6. I'm going to plot it. So I can't tell you what the distance between those 2 points is, but the distance I'm trying to find is the distance of this line segment. You know, how many units long is this? And I couldn't tell you by looking at it, but I could be clever and find the distance using a bit of geometry. And the geometrical way to find the distance would be to make a triangle that kind of encapsulates these points and that line segment that I just drew. So I'll draw a horizontal line from the bottom point and a vertical line from the top point. And what I've done is I've created a right triangle. And the nice thing about right triangles is that they obey the Pythagorean theorem. So the sides of this triangle obey the Pythagorean theorem, which says a squared plus b squared equals c squared. This is a triangle that has a right angle. The right angle is right there. When I go to label the sides of a right triangle, if I want to use the Pythagorean theorem to find the distance between the 2 points, which is the same as the distance of that line segment, the black line that I drew has to be a C, because that's the hypotenuse of the right triangle. The pink sides that I drew, it wouldn't matter if I called one, which one I'm going to call A and B. Generally, I draw an A for the horizontal side and make B the length of the vertical side. So I'm going to find the length of that hypotenuse, which is the length of that side of the triangle, which is the distance between the 2 points by using the Pythagorean theorem. A is the distance between the point that I drew and this corner of the triangle, and that's 1, 2, 3 units long. So A is going to be 3 units long. B is the distance between that corner of the triangle and the top of the triangle, which is 1, 2, 3, 4 units long. So if I take those 2 numbers and plug them into the Pythagorean theorem, I can solve for C and get the distance between the 2 points that I want. So I'm going to use a squared plus b squared equals to c squared. Instead of a squared, I'm going to write 3 squared. And instead of b squared, I'm going to write 4 squared. And I'm going to leave the c squared alone at c squared. 3 squared is 9. 4 squared is 16. So the left-hand side reduces to 25. The right-hand side is a c squared. Usually when I have a squared in a problem and I'm solving, I either set it equal to 0 and solve by factoring, or I solve by square rooting plus or minus square rooting. I'm going to solve this by square rooting. And this is one of the few times when I solve by square rooting that I'm not going to plus or minus the square root, because the answer is the distance between 2 points, and distance is always positive, and the negative answer to this isn't going to be the distance between 2 points. So I'm going to solve for c using square roots. The square root of c squared on the right side is going to be c. The square root of 25 is going to be 5. and then the distance, I don't know what the units are measured in, so the distance between the 2 points is 5 units. Completely done with this problem, but this is a perfect time to interject or introduce or make you remember something that you may have forgotten. There's another way to find the distance between 2 points, and it will give you exactly the same answer without having to break out and draw a really accurate triangle. And the alternate way to get the distance between 2 points, it won't give you a different answer, is using the distance formula. And the distance formula says d for distance equals, has a big square root, and then under the square root it has the difference of the x coordinates in a parentheses with an exponent of 2, then a plus sign, and then the difference of the y coordinates inside a parentheses with a square. So I'm done with problem 2, but if I didn't want to use the Pythagorean theorem to get the distance between 2 points, I can get the distance using the distance formula. So let me just show you how to do that. This is extra, but you can do either. For problems 1, 3, and 5, when you're asked to find the distance between the 2 points, you really don't have to use the Pythagorean theorem. You can use the distance formula. The distance formula says take the difference of the x coordinates, that's going to be 4 minus 1, square them, put a plus sign, and then do the difference of the y coordinates and square them and put a plus sign between those two quantities. Unlike slope, it doesn't matter if you switch the order of the in the parentheses, it won't matter. You'll get the same answer because you're gonna it will net out. When you square it, it's gonna make that a non-issue. So the distance between my 2 points, first parentheses comes out to be 3. I'm going to need to square it. Second parentheses comes out to be 4. I'm going to need to square it. The distance between my 2 points is the square root of 9 plus 16. And all of a sudden, I get exactly the same setup as the Pythagorean theorem, and I get the distance between my 2 points is 5. You'll notice that the numbers are basically identical. It's just that Pythagorean theorem, I don't throw the square root in until the last step, and distance formula, the square root's there the whole time. So when we get to a test, the instructions for the questions going to say find the distance between the 2 points, and if you don't want to graph and use the Pythagorean theorem, and if you just want to use the distance formula, that's completely fine. All right, so let me move down to problems 3 and 4, which I can't seem, I started doing, and then I had a mistake on my problem 2. Well, not a mistake, but yeah, it was something I wanted to say differently. So here's problems 3 and 4. And look, I started doing problem 4, and I'm going to find the distance between the 2 points using the distance formula, just because most students wind up liking it to find the distance between 2 points better than the Pythagorean theorem. I'll go back and do the Pythagorean theorem. Ultimately, I need to find the distance between my 2 points. So in the first parentheses, I'm going to find the difference between the x coordinate of the second point minus the x coordinate of the first point. I have a double negative. When I have a double negative, I usually capture that second negative in a parentheses. And then in the second parentheses, I'm doing 1 minus 5 squared, which is the difference of the y. So I just use the distance formula of the square root of x2 minus x1 squared plus y2 minus y1 squared. The double negative in this parentheses comes out to be negative 1 plus 3. And that's going to be 2 squared, because negative 1 plus 3 is 2. The 1 minus 5 comes out to be negative 4 squared. This gives me the distance equals 4 plus 16, because 2 squared is 4. Negative 4 squared is 16. So I'm going to get the square root of 20. We're going to reduce a decent number of square roots this semester. If you had me for intermediate algebra, I have a calculator that I use for intermediate algebra that rocks on square roots. If I entered square root of 20 on this calculator, it would tell me it reduces to 2 square root of 5. That's the distance I'm going to want for this answer. The distance between the 2 points is 2 square root of 5 units. There's multiple ways to get there without a calculator. This lovely calculator we need for our class because it does some things that my other calculator doesn't, but it doesn't give me a very nice answer. It doesn't give me an answer that's suitable. Probably the nicest way to get to the 2 square root of 5 is to say the square root of 20 is the square root of 4 times the square root of 5, is because 4 times 5 is 20 and the square root of 4 is 2. There's a way to get this with factor trees that I teach in intermediate algebra. If you had me for intermediate algebra, you probably have this calculator, and then just use both calculators on the test. This one for reducing radicals and maybe working with fractions, this one for working with graphs. If you don't own this calculator, you don't need to run out and buy it. It's a Casio FX 115 ES Plus, costs about $17. I always get mine at Walmart. I'm sure they sell them at other places. But nevertheless, we need to be able to reduce square roots. If you don't remember how to reduce square roots, if you get a calculator that does them, I'm fine with that. If you don't want to get a calculator that does them, you absolutely don't have to. I can reteach you how to reduce square roots. I think it's in section 4.4 or 4.5 of my intermediate algebra material if you wanted to peek at the video. So I found the distance between 2 points. Let me show you how to do it the other way. The other way would be to plot the point -3, +5, and the point -1, +1. And then I'm going to draw the triangle. That's the distance I'm trying to find. I need to draw a horizontal line from the bottom point, a vertical line from the top point. And the distance I'm trying to find is going to be that hypotenuse of that triangle, which is a C. The horizontal length I usually call A, and that's 2 units, so my A is going to be 2 units. The vertical length I usually call B, which is 1, 2, 3, 4 units. So my B is going to be 4 units, and I'm going to use the formula A squared, which is going to be 2 squared, plus B squared, which is going to be 4 squared, equals C squared. This is going to give me 4 plus 16 equals C squared. You're seeing exactly the same numbers. This is going to give me 20 equal to C squared, and then I square root. I don't need plus or minus because the negative square root is not going to be applicable because this is not a this is a length, and lengths can't be negative. And this is going to give me 2 square root of 5 equal to C. And so my answer to problem 4, the distance, I'm just going to say distance equals 2 square root of 5. And when you're doing your homework, if you want to use the distance formula, you don't have to draw triangles. The plotting the points was just supposed to make your life easier, which it may or may not do. Turns out that the next 2 problems, when I go to plot them, it's going to be really easy to find the distance between the 2 points, and I won't even need to draw a triangle. I'll show you what I mean here in a second. Alright, so problem 6, if I want to use the distance formula to find the distance between the 2 points, I'd go distance equals difference of the x's squared plus the difference of the y's squared. For the distance of the x's squared, I'm going to put 5 minus 5 squared. For the distance of the y squared, I'm going to put 2 minus 1 squared. This is going to give me distance equals, first parentheses is going to come out to 0 squared. Second parentheses is going to come out to 1 squared. That's going to be 0 plus 1. So that's going to be the square root of 1. And 1's its own square root. If on my calculator I did second square root of 1, I'd get square root of 1 equals to 1. So the distance in this problem between the 2 points is 1. So the distance between my 2 points is 1 unit. If I wanted to get this using graphs, this is the rare time my graphs won't need a triangle. Let me show you how to get this distance using a graph. If I plot at the point 5, 1, so I'd go 5, 1, and I plot at the point 5, 2, I'd go 5, 2. If I connected those lines right there, those points are on a vertical line, and that's the only time. Well, if I have a vertical line or a horizontal line, I could just count the spaces between the line, and that will be the distance. If I have a slanted line, I have to draw a triangle and use Pythagorean theorem to find my distance. But if I have a horizontal line or a vertical line, the distance between the 2 points is the distance, and this distance is going to be 1, because to get from this point to that point is just one box, its distance is 1. So I could have gotten that way easier with a graph than using the formula. Alright, so that's the first 5 problems. We'll just keep mowing through this section. It's probably going to be a 2-part video. The next work, let me change this point. I don't like having 14 that doesn't fit on my graph. So I'm going to say plot the points on a graph, then the midpoint of the line that connects the midpoint of the line segment that connects the points. Oh, that's really poorly worded. Let me change this to the point 4, 8, I guess is fine. So how do I find a midpoint? So let me do this graphically. And it's going to be kind of hard to do graphically because it has a fraction answer, but I'll show you what I've intended when I wrote this problem. So I'm going to plot the points on a graph. I'm going to plot the point 1, 2 and the point 4, 8. And then I'm going to connect them with a line segment just like I did when I was trying to find the distance between the 2 points. What this asks me to do is to find the midpoint of this line segment. The midpoint of a line segment is the point that's equidistant between the 2 points, and I think it's right about there. I think, so this is the point 4, 8. This is the point 1, 2, and it looks to me like that point right there is the midpoint because it cuts the line into 2 equal halves. And if I had my best guess, that looks like it's about the point 2.5, comma 5. I have a decimal in my answer. I'm going to live with that because when I just instinctively said that point's x-coordinate's about 2.5. So I believe that's the answer, but quite honestly, getting the midpoint of a line segment by looking at a graph, that's kind of hard to do. So to make sure that this is actually the midpoint, I'm going to use the midpoint formula. And the midpoint formula is a way to get the midpoint of the line segment that connects 2 points. And because it's a point, the midpoint formula is going to be written in point form. And as a point, the x-coordinate of the midpoint is going to be x2 plus x1 over 2. And the y-coordinate of the point is going to be y2 plus y1 over 2. So already into the second section, we're getting a boatload of formulas which aren't going to be given to you on the test. If the day before the test by 2 in the afternoon, you show me that you've done all the odd-numbered problems in each of the sections that I lecture on, then you're allowed to use a note card. You can write whatever you want on that note card, and the formulas are definitely something I would put on there if I don't have them memorized. All right, so let me get the midpoint using the midpoint formula. So the midpoint is going to be a point. The first point, I'm going to add the x-coordinates and divide by 2. So 4 plus 1 over 2. And then the y-coordinates, I'm going to add the y-coordinates and divide by 2. So my midpoint is going to equal 4 plus 1 over 2, which is going to be 5 over 2. And then 8 plus 2 over 2, which is going to be 10 over 2. For an answer, if I'm doing it by hand and not using my graph, I'd probably say the midpoint is 5/2 comma 5. But if I had to graph that, it's a lot easier for me to graph 2.5 as a decimal. I'd absolutely take a decimal answer for this midpoint. You definitely wouldn't have to give me a fraction. So for each of the problems 7, 8, 9, 10, 11, and 12, I'm going to do exactly that. I'm going to plot the 2 points and try to guess out what the midpoint is, and then I'm going to confirm it by graphing. My answer needs to say what the midpoint is, needs to identify that midpoint, and it'd be nice to have it plotted on the graph. Alright, so for number 9 and 10, I'm going to do my number 10. I'm going to plot the point -3, +5. So the point -3, +5 is about there. The point -1, +1 is about here. And now I'm going to connect these 2 points with a line. And it looks to me like, boom, right there's the midpoint. That looks like it's the point -2, +3. My guess as to what the midpoint is, it is the point -2, +3, I think. But even with graph paper and a ruler, my graph could still be kind of cruddy. So let me try to confirm that before I say that the midpoint is actually that. So the midpoint can be found. It's a point, so I'm going to write a point. And the left-hand point, I add the 2 x-coordinates. The x-coordinates are -1 and -3, and I divide by 2. And I add the 2 y-coordinates, 1 + 5, and divide by 2. This is going to give me -4/2, and then comma 6/2. -4/2 is -2, 6/2 is 3. And for my answer, this would be sufficient. It'd be nice if you said this was the midpoint. And I'm going to just scribble down here that the midpoint is that point -2, +3. It's so nice when they're not fractions. I can get them more accurately on my graph. All right, let me do 12. 12, I need to plot the point 5, 1. And the point 5, 2. That's this lovely little line segment right here. Here's the point 5, 2. Down here's the point 5, 1. The midpoint is halfway between those two, and I think that's the point 5, 1.5, because it's definitely x equal to 5 because it's on the vertical line that goes through 5 on the x-axis, and the halfway between 1 and 2 is 1.5. So I think the midpoint is 5, 1.5. That's a really tough drawing to see on this because it's so small. But let me find the midpoint to make sure that I actually have the right answer. So the midpoint is equal to, comma, boom. When you do the midpoint, it doesn't matter the order that you put the x's and the y's in. If you switch the order, you'll not get bad answers like you might if you're doing slope. So the first coordinate is add the x coordinates, square them, or divide by 2. The second is you add the y's and divide by 2. This is going to give me 10/2, comma 3/2. And then if I'm doing it by hand, I'd probably say the midpoint is the point 10/2, which is 5, and I'd leave the fraction at 3/2. When I'm doing it by graphing, I'd probably write the decimal just because it's easier for me to think that's the point 1.5 rather than 3/2. So if this was a test question and it asks you to sketch a graph and find the midpoint, I'd want to see this. I'd want to see a little line segment with each of the points, a mark for the midpoint, and the coordinates of the midpoint on the graph. And if you give the points as decimals or fractions, it's just whatever kind of happens. All right. Next group of problems, again, if I look at the problems without the instructions, they don't tell me anything. Thank gosh I haven't asked to graph again. This just says determine the slope of the line that connects the 2 points. In order to find the slope of the line that connects 2 points, I need to know the slope formula. And the slope formula is the only one of the 3 formulas that we're using today so far that the order is dead on important. The slope of a line is going to be found by using the slope formula, which is y2 minus y1 over x2 minus x1. That's the y-coordinate of the second point minus the y-coordinate of the first point divided by the x-coordinate of the second point minus the x-coordinate of the first point. So for problem 14, to find the slope of the line that connects the 2 points, I'm going to write the letter m for slope. In the numerator, I'm going to take the y-coordinate of the second point minus the y-coordinate of the first point, which is 14 minus 2. In the denominator, I'll take the x-coordinate of the second point minus the x-coordinate of the first point, which is 4 minus 1. This is going to give me 12 over 3. And my answer for problem 14, the slope of the line that connects those 2 points, I'm just going to write m equals to 4. I'm not even going to write the word slope. If you write m in a algebra class, we know that it stands for slope. All right, so you should be able to do 13. You probably should be able to do 15 and 17 as well, but there might be a trick that you stumble on that messes you up. So for problem 16, to find the slope of the line between those 2 points, form a fraction. In the numerator, do y2 minus y1, which is 1 minus 5. In the denominator, x2 minus x1, that's negative 1 minus negative 3. That second negative picks up its own parentheses. This gives me m equals negative 4 in the numerator, which is 1 minus 5. In the denominator, negative 1 minus a negative 3 reduces to negative 1 plus 3. That gives me m equals to negative 4 over 2. And my answer for problem 16, the slope of the line between the 2 points that are given is negative 2. So you should be able to do 15. You might get stuck on 18 and or 20. This is when we start getting fractions with zeros, it's important to remember that fractions with 0 in the numerator equals 0. Fractions with 0 in the denominator are undefined. So that trick is probably going to make its way into the next 2 problems. So for problem 18, to find the slope of the line between the 2 points that are given, I'm going to write m equals, and I'm going to subtract the y-coordinate of the second point minus the y-coordinate of the first point, and then divide it by the x-coordinate of the second point minus the x-coordinate of the first point. That's going to be 1 over 0, and for this, the slope is going to be undefined. So the answer is going to be m equals undefined. My videos get so long, I feel the urge to draw a graph right now and explain what undefined slope looks like, so let me do that real quickly. If I plot at that point 1, 2, 3, 4, 5, 1, and 5, 2, and drew a line between those 2 points, those 2 points form a vertical line. Vertical lines have undefined slopes, and their equations only have an x and they don't have a y. So it's important to know or remember, because you did this at some point in your past, vertical lines, that's lines that are parallel to the y-axis, they have undefined slopes, and their equations only have an x. I wasn't asked to find the equation of that line that I just drew, but that line would have an equation x equal 5, because every point on the line would have an x coordinate of 5 and the y coordinates would vary. Alright, little extra there, but I'm sure this comes up in a bit. Find the slope. So slope is the y-coordinate of the second point minus the y-coordinate of the first point. Just had a hiccup. So for number 20, the slope is the y-coordinate of the second point minus the y-coordinate of the first point divided by the x-coordinate of the second point minus the x-coordinate of the first point. I get 0 in the numerator. Both the numbers in the denominator are negative, so I add them and keep them negative. Any fraction with 0 in the numerator is equal to 0. So my answer to problem 20 is the slope is equal to 0. And then some things that are important. If I went and graphed these 2 points, the point 1, 2, 3, 4, 5, 6, and 2, and 1, 2, 3, 4, 5, 6, negative 7, and 2. If you connected those 2 lines with a point, again, this is extra that's not required, they form a horizontal line. And all horizontal lines have a slope of 0. So again, that's not necessary, but it's probably nice to just mention right here because it fits. Vertical lines have undefined slope and their equations only have an x. Horizontal lines have 0 slope and their equations only have a y. So the equation of any horizontal line only has a y. And this line right here, its equation would be y equal to 2 because every point on the line, even the points that I haven't marked, have a y coordinate of 2. Now, that's way excess. The only thing we had to do for problem 20 was find the slope of the line that connects those 2 points. But, heck, that was extra. It hardly hurt to give you the extra. All right, so you should be able to do 19. The next few problems ask me to sketch a graph of a line and label at least 4 points. Well, I can tell the graph of this is going to be a line because the x and the y don't have exponents. There aren't any fractions with x's or y's in the denominator, so the graph is going to be a line. And the easiest way to graph a line is to plot the y-intercept and then use the slope to find more points. You can only do that if the line's written in the slope-intercept form. Slope-intercept form is y equals mx plus b form. The lines that are given in problems 21 and 22 are written in y equals mx plus b form. In problem 22, the b, which is the y-intercept, is negative 2. So this tells me the y-intercept is the point 0, negative 2. And the slope is 1/4. And that tells me to move from point to point on the graph. The numerator is the y direction. If it's negative, it's up. If it's positive, it's up. If it's negative, it's down. The denominator is the x direction. If it's positive, it's right. If it's negative, it's left. This slope is positive 1/4. That tells me I can get from point to point on this graph if I go up 1, which is the y direction, positive y is the up direction, and right 4 because positive x is a x direction that's positive. So I'm going to start off and I'm going to plot the y-intercept, which is the b, which is the point 0, negative 2. That's the first point. I need 3 more. For the second one, I'm going to go up 1 and then right 1, 2, 3, 4. And that takes me to the point 4, negative 1. And then I'm going to do the same. I'm going to go up 1, right 1, 2, 3, 4. That takes me to the point 8, 0. And then go up 1, right 1, 2, 3, 4. Took me past the 10 to an 11 and then a 12. And my next point is going to be the point 12, 1. And now I'm going to connect those. If I've done these points properly, they should all lie exactly on the same line. They shouldn't have a point that's kind of way off, out of whack. So when I draw the line, I connect those points. So I've sketched a graph. I've labeled at least 4 points. Usually when I'm drawing a line, I put little arrows at the end signifying that it doesn't end, but sometimes I forget those arrows. It hardly matters. So for your graph, when you go to do problem 21, you're going to plot negative 5 on the y-axis and you're going to go up 2 and right 3, because the numerator is the y direction. If it's positive, it's up. If it's negative, it's down. The denominator is the x direction, and the denominator of a fraction is generally positive, so it's usually to the right I have to go. Problem 24 is a little bit different because it's not written so nicely for me to get started. I have to think of problem 24 as y equals 1/4 x plus 0. So in this case, the b is going to be 0. So the y-intercept is going to be 0, 0. So I'm going to plot 0, 0. The slope's exactly the same number. So I'm going to go up 1 and right 4 from that point. Similar year 23, the y-intercept's going to be 0, 0. So my first point I'm plotting is the point 0, 0, and then up 1, right 1, 2, 3, 4, and then up 1, right 1, 2, 3, 4, and then up 1, right 1, 2, 3, 4. This right here is the point 4, 1. This is the point 8, 2, and then 10, 11, 12, 3. So I filled in the 4 points, and my instructions said give me at least 4 points. I gave 4 points. I could have done more, but I'm kind of out of room. Now I'm going to connect those points with a line. Put a little arrow at the end of this line, a little arrow at the end of that, and that would be completely suitable. When I go to do problem 26, I think I'm going to run out of room, and I'll teach you how to go backwards to get more points. So for problem 26, y equals 6x plus 1, the y-intercept in problem 26 is going to be the point 0, 1, because the b in this problem is 1. The slope is 6, and the slope isn't written as a fraction. I can certainly make it a fraction by writing it over 1. And that's going to tell me to go up 6, and the denominator tells me to go right 1. So let me see how that fits. So I'm going to start off with the y-intercept, which is the point 0, 1. I'm going to go up 6, 1, 2, 3, 4, 5, 6, right 1. That takes me to the point 1, 7. And then up 6, 1, 2, 3, that's 10, 11, 12, 13, right 1. That's going to be the point 2, 13. Unfortunately, going up 6 and right 1 again is going to really mess me up. So let me do double opposite. I'm going to go down 6 and left 1. Doing exactly the opposite direction will still get a point on the line. So if you just change both directions and go down 1, 2, 3, 4, 5, 6, left 1, that point's still going to be on my line, and that's going to be the point, what's that, -1, -5. So if you start running out of room going the direction that the slope takes you to, double change up to downs, right to left, and that will give you points that lie on a line. Of course, when you start, if you're not using graph paper, then your graphs aren't going to be super accurate, and I don't care. You don't need graphs to look as nice as this, if these even look nice to you. But this would be perfect for problem 26. It fits the criteria. I drew the line and labeled 4 points, good enough for me. I think for year 25, you're probably going to fit really nicely on the screen. 27 and 28, as well as 29 and 30, they're not as nice. So let me try to do something better with 28 and 29, or 28. So for 28, I'm going to rewrite it so I can easily graph it. Because in the form it's in, it's not in y equals mx plus b form. This is in some sort of standard form. And in standard form, I can't tell you any points. And so I'm going to get it in standard form by solving the equation that's given to me for the y. So I'm going to minus 4x from both sides. That's going to give me 5y equals minus 4x plus 10. And I'm going to divide by 5. That's going to give me y equals negative 4/5 x plus 2. The graph of 4x plus 5y equals to 10 and the graph of y equals negative 4/5 x plus 2 are exactly the same, but this is easier to graph. The y-intercept is 2, which I'll write as the point 0, 2, and the m is negative 4/5. That tells me I need to go down 4 because there's a negative 4 and right 5 because the 5 is positive. So I start off, I graph the point 0, 2 and go down 1, 2, 3, 4, right 1, 2, 3, 4, 5. That's the point 5, negative 2. Down 1, 2, 3, 4, right 1, 2, 3, 4, 5. That's the point 10, negative 6. The next point's going to shoot off my screen, so let me flip both of these. Instead of going down 4, I'm going to go up 4. Instead of going right 5, I'm going to go left 5 from that point 0, 2. So if I go up 1, 2, 3, 4, left 1, 2, 3, 4, 5, that's the point negative 5, positive 6. I'll get that fourth point I was supposed to get. All those points are going to be smack dab on the same line, which is perfect. So now I'm just going to connect these points. You don't have to give the same 4 points as me. If you started going backwards earlier than me, that would be completely fine. All right, so give number 27 a go. We just have 2 more problems in this grouping, and then we'll move on to another kind of problem. So I'm going to solve this for y again. So when I go to do problem 30, I can't graph so easily an equation of a line that's not solved for y. So let me minus 5x from both sides. When I do this, it gives me negative 2y equals negative 5x. Now I'm going to divide both sides by negative 2. On both sides, the double negatives cancel out to be positives. This is going to give me y equals, and then it's going to be 5/2 x. And I need to think of this as y equals 5/2 x plus 0. And the y-intercept is going to be that 0, 0. So for this graph, the y-intercept is going to be the point 0, 0. There was no number after the x. I inserted that 0. And the slope is 5/2. So I'm going to go up 5 and right 2. So up 1, 2, 3, 4, 5, right 2. Up 1, 2, 3, 4, 5, right 2. This was the point 2, 5. This was the point 4, 10. Let me double flip these and go down 5 and left 2. So down 1, 2, 3, 4, 5, left 1, 2. That'll take me to another point, and I should probably label these points. There's the point 0, 0. That's the point negative 2, negative 5. And I'll graph my line. Certainly don't need to use multiple colors. Don't need to draw arrows at the end of your line, but it's kind of nice if you do. All right, so this is, probably the best way to draw a line is to take the equation, solve it for y, plot the y-intercept, and use the slope to get the rest of the graph. The next problems, the problems from 31 through 38, they force me to do some algebra, and the algebra actually finds points on the graph, and anytime I'm asked to graph a line, if I do algebra to find 2 points, 2 points is the absolute minimum I can do to draw a decent line, and I'm going to exploit that. So in the next group of problems, the problems from 31 through 38, again, if I look at the instruction, the problems without the instructions, I don't know what to do. 31 through 38 says find the x and the y intercepts and then sketch a graph. And then it says it will be enough to label 2 points. In the last problems we were drawing 4 points just to get you used to using the slope to find points. In these problems, because I'm asked to do algebra to find the x and the y intercept, the x-intercept is a point on the graph. The y-intercept is a point on the graph. The algebra that I'm asked to do for this problem is going to find 2 points on the graph. And what I'm going to do is after I find the x and the y-intercept, I'm going to plot the x-intercept on the x-axis, I'm going to plot the y-intercept on the y-axis, and then I'm just going to connect those 2 points with a line, and I'm not going to have 4 points in my graph. I'm not even going to know the slope of the line, but I'm still going to get an accurate graph. So to find the x-intercept, we let y equal to 0 and solve for x. So in problem 32, to find x-intercept, I'm going to go 3x plus 0 equals 15. This will give me 3x equals to 15. And I'll divide both sides by 3 and get x equal to 5. X-intercepts always are points, and the y part of any x-intercept is 0 because I plugged in 0 for y, so there goes a 0 in the y part. The x part is 5. My x-intercept is the point 5, 0. Now I'm going to find the y-intercept. I find the y-intercept by letting x be 0. So I'm going to go for problem 32, 3 times 0 plus y equal to 15. That's going to give me 0 plus y equal to 15, which will give me y equal to 15. Y-intercepts always have 0 as their x, so I'm going to write the point 0, 15. I'm going to plot the point 0, 15. Notice my y-axis is kind of scaled differently than my x-axis, because when I scaled my y-axis by 1 up to 15, it just got really, it was hard to read the line. I have 2 points. I don't know the slope of this line. Doesn't matter. If I have 2 points on a line, I can draw the line without actually using the slope or using any strategy to find extra points. So for each of the problems between 31 and 38, that's all we're going to do. We're going to find the y-intercept and the x-intercept, say what those are in terms of your answer, plot those, and then draw the line that connects them. So you can find an equation of a line without using the slope. If I did use the slope, I would have to solve this for y, and I would have gotten y equals minus 3x plus 15. The y-intercept is going to be 0, 15, which I figured out already. And the slope is going to be negative 3 over 1, so I would go down 3 and right 1. So I'd go down 1, 2, 3, right 1, down 1, 2, 3, right 1, down 1, 2, 3, right 1, down 1, 2, 3, right 1. But my graph isn't incremented so nice to do that. But you could have done it that way, gotten a graph that way. But it's not necessary. If you have 2 points, you can get the graph by of a line just by connecting those points. All right, 34. Let me find the x-intercept. To find the x-intercept, I plug in 0 for y. So I'm going to go 3x minus 6 times 0 equals 9. That piece turns into 0, so that's 3x equal to 9. And then divide by 3. I'm going to get x equal to 3. For my answer, the x-intercept is going to be the point 3, 0. I'm going to plot that on the x-axis. Now I'm going to find my y-intercept, which is going to be a fraction. It's okay if you give it to me as a decimal. I'm going to go 3 times 0 minus 6y equals to 9. The 0 piece will go away and give me minus 6y equal to 9. Then I'm going to divide by negative 6. And this gives me y equals, that fraction reduces to 3 halves. Divide, yes, 3 halves, 3 halves. And I'm going to move the negative up to the numerator. Technically, it reduces to 3 over negative 2. but I don't like negatives in the denominator as a fraction, so I bumped it up to the numerator. It'd be completely okay and probably better because we're having to graph if you wrote it as 0, negative 1.5. That would be completely fine because negative 3/2 is equal to negative 1.5. Let me plot that. There's my 0, negative 1.5, which is the y-intercept. I have both the x and the y-intercept, so now I can sketch a graph without actually knowing what the slope is. If you wanted to, or if I wanted to, I could have solved this equation for y and did the graph like I did the last group of graphing problems, but doesn't really feel necessary for any of these problems. Next problems are quite messy, so we're going to have to just deal with some fractions. Let me work on 36 and find the x-intercept. For the x-intercept, I'd go 2/3 x minus 1/2 times 0 equals to 5. This piece goes away, so this gives me 2/3 x equals to 5. Technically, I need to divide both sides by 2/3. On the left side, the 2/3 cancel, and I have an x. On the right side, I have a mess. What I have is 5 divided by 2/3. And it's probably easier to think of it with a division sign than that ugly fraction. And that's the same as 5 times 3/2, because dividing by a fraction is the same as multiplying by the reciprocal. And now if you're multiplying an integer by a fraction, you multiply the integer by that numerator, and I'll get 15/2. So for this problem, the x-intercept is going to be 15/2, comma 0, or if you want to, 7.5, comma 0. So for my x-intercept, it's going to sit right on the x-axis. It's going to be 7.5, comma 0, or 15/2. The y-intercept I'll do similarly. I'll try to squeeze it down here. So for the y-intercept, I'm going to go 2/3 times 0 minus 1/2 y equal to 5. This is going to give me minus 1/2 y equals to 5. And now I need to divide both sides by negative 1/2. There are other ways to do this, but this is what most students seem to tolerate best. On the left-hand side, I cancel out the negative 1/2, and I get a y. Now on the right-hand side, I should write this as 5 divided by negative 1/2. I'm going to flip it to a multiply, so it's going to be 5 times 2 over negative 1. Flipping the fraction, making the multiply. This is going to be 10 over negative 1, and 10 over negative 1 is negative 10. So the y-intercept is going to be 0, negative 10, because that 10 over negative 1 turns to negative 10. Unfortunately, it jams right into where I started writing my answer for these x-intercepts, because I didn't know what the y-intercept was ahead of time. So let me go ahead and plot that point, even though it kind of jumbles up things, and make the line that I needed to make. Alright, so this would be part of the answer. You need to say what both the x and the y-intercept are, and then you need to plot the points and sketch a graph. Because the algebra produced 2 points on the graph, I didn't take the time to solve it for y and use the slope and the y-intercept. Alright, so 38 will be the last problem in this part of the video, and then I'll make a part 2 for the 39 through 56, the rest of it. So first I'm going to find the x-intercept for problem 38 by going 2/7 x minus 0 equals to 4. That gives me 2/7 x equals to 4. And then I'm going to divide both sides by 2/7. On the left side, I'm going to cancel out the 2/7 and get the x. On the right side, I'm going to write this as 4 divided by 2/7, which is the same as 4 times 7/2. I could cancel the 2's, or I could multiply the 4 and the 7 and then reduce the fraction. I'm going to multiply the 4 and the 7 and then reduce the fraction 28 over 2, which is 14. So part of my answer to problem 38, the x-intercept is the point 14, 0. Now I'm going to try to squeeze in the y-intercept. The y-intercept, I'll go 2/7 times 0 minus y equal to 4. That gives me minus y equals to 4. And I'm going to emphasize that that's really minus 1y equal to 4. When there's not a number written in front of the letter, there's an implied 1. Now I'm going to divide by negative 1. On the left-hand side, the negatives cancel, and I'm left with a y. On the right side, 4 divided by negative 1 is negative 4. That's going to tell me that the y-intercept is the point 0, negative 4. Now I'm going to plot those 2 points, so that's part of my answer to problem 38. Plot the point 14, 0, kind of estimated anyways, and 0, negative 4. And now connect those 2 points, and I'll be done with problem 38 because I've done everything. It said find the x and the y intercepts, which I did, label 2 points, and make a line. All right, so that will be the first half of section 2.2, and then we'll do the next half, which should be a little bit shorter. So let me pause the video, and then we'll come back and we'll finish up the section.